Welcome everybody to this catch and do session, and welcome to our catch and do tank here at BLUMORPHO. We are so happy to have you today for this new session of our catch and do's advanced materials, the performance versus sustainability dilemma. And for this catch and do, we are very happy to have with us Henning from MITSUBISHI Chemical Advanced Materials. Before we start, quick introduction. So on BLUMORPHO side, you will see three persons today. So myself, Henning, innovation developer at BLUMORPHO, Alice, in charge of investors relations and also innovation developer at BLUMORPHO. So hi, Alice.
Hi, everybody. Nice to see you.
And last but not least, Regis, that will step in at the end of the webinar, which is our CTO here at BLUMORPHO. So, think about BLUMORPHO. In a nutshell, we are the innovation partner and trusted third party of leading organizations for technology scouting and innovation sourcing. We are a team of deep tech and data experts committed to deliver disruption for a positive impact and working with the entire value chain of innovation, of course. So we basically implement three actions. So we are customer-centric to deliver new value propositions and new business models. We operate open innovation to generate deal flow and activate collaboration. And we also co-create new ventures. This session is sponsored by the Oasis European projects funded under the H 2020 program. So in a nutshell, Oasis is an ecosystem of advanced materials facilities around Europe. It gathers 12 pilot lines and additional advanced manufacturing centers, covering the product life cycle from material synthesis to end products. And Oasis aims at supporting the development of lightweight and multifunctional components for a wide range of industrial fields. So thank you also, Oasis, for making this catch and do possible. Last but not least, our speaker today, Henning Bloech from MITSUBISHI Chemical Advanced Materials. So Henning is the Global Director of Sustainable Solutions for MITSUBISHI Chemical Advanced Materials, part of MITSUBISHI Chemical Europe. Before we start, I wanted to let you know that the webinar is recorded and that you will get access to the recorded version. This webinar is interactive in a lot of ways. So you will have the opportunity to share your views during the live surveys across the webinars. And at the end of the webinar, we will also take all the questions. So do not hesitate along the way to shoot all your questions. We won't miss them, and we will take them back at the end of the webinars to ask them directly to Henning. So let's start. I think, Alice, you have some survey for us.
Yes. So can you hear me right?
Yeah, we do.
Perfect. So this is a poll that you should see popping up on your screen right now. Can you see it, Julien?
I'm not supposed to see it, but
yeah.
Maybe can you see it?
Yeah, it's perfect. So right now you see the survey popping up on your screen. So the idea here is to know what keeps Henning up at night. So is it to have all Mitsubishi Chemicals materials from bio-based or recycled sources, or is it the end of life of goods made out of Mitsubishi Chemical materials, or the adoption of sustainable materials along the value chain, to reduce energy and water consumption of the product life cycle, or the oil shortage and the end of oil-based plastics. So the idea here is for you to give your opinion on what keeps Henning up at night, and you will see that you will have a lot of surveys like this popping up on your screen along this catch and do, so you can give your opinion and we will comment the results. So I will now shut the poll and give you back the floor, Julien.
Thank you, Alice, for this. So now, Henning, we will start with a quick introduction of your background. And so can you introduce yourself and also your role, sorry, at MCAM?
Absolutely. First of all, thank you very much for having me. This is exciting. This is a new format for me, so this is great. A great experience. Thanks to all the attendees for your interest in this. So my role is a Global Director of Sustainable Solutions at MChem. So I lead the development and implementation of our sustainability strategy. So that includes, our carbon management. That includes our circular economy. Looks at products. Looks, upstream, downstream. Overall, a big picture view of sustainability, and then making sure it can get implemented across the organization. We have a specific philosophy regarding sustainability called Kaiteki, which is that's the Mitsubishi Chemical philosophy, which is basically the management approach to sustainability at Mitsubishi Chemical and Mitsubishi Chemical Advanced Materials as well.
Thank you. So a lot of exciting activities, I'm sure. So now
let's start.
So now I suggest we start and we get into the topic of sustainability and the sustainability in advanced materials. So first question for you, Henning. What are the main drivers for developing sustainability strategies and afterwards implement them at MChem?
Well, first thing is, of course, to be a good corporate citizen, right? Do the right thing. So I think that's driving MChem. That's driving a lot of other corporations as well, because it's basically, we work in the same markets. It's our right to operate, and we absolutely want to give back more than we take. So that is a core philosophy at MChem. Other drivers, of course, include regulatory drivers that not just we, but all of our competitors and all of our suppliers and customers are also facing. Particularly in Europe, there's a strong move towards more regulatory drivers regarding sustainability. We're in the plastics industry, so we make advanced materials, but polymers. So there's a specific focus on that. And of course, because of those regulatory drivers and being a good corporate citizen, our customers want to do the same thing. They also try to reduce their carbon footprint. They try to use more sustainable materials. So they are a very big driver for us as well, working closely with our customers and help them and provide solutions for them so they can meet their needs and we can meet their expectations.
Great. So regulation and clients in the end. They decide everything. So maybe we can have a look at the results of the poll and comment. So Alice, can you share? Thanks.
Yeah, I'm sharing the results now.
So what
go ahead, Julien.
Okay, so what we see that 30% think that the adoption of sustainable materials along the value chain is important, as well as reducing energy and water consumption on the whole product life. And the 20% think that what keeps you up at night is that MChem should have only bio-based or recycled materials. So and 10% think that the oil shortage and the end of oil-based plastic is a big concern for you. So what's your comment about this?
Well, from my point of view, the one I probably would have picked is the adoption of sustainable materials along the value chain, because that kind of covers our suppliers, covers us. We sit basically right in the middle and covers our customers. And if we can get this adoption across along that value chain, ultimately we will address most of the other points as well. Basically, none of these really keep me up at night. I sleep very soundly. It's my kids that keep me up at night, but I think they're all valid. So they're all valid concerns, and they kind of feed into one another, and they build onto one another. But if I had to pick one, it would be the adoption of sustainable materials along the value chain.
Okay.
Thank you very much.
Thank you.
So, suggest we go on with the next topics about the obstacles to deploy sustainable strategies. So I think, Alice, you have a new poll for us, right?
Exactly. So the new poll should be popping up on your screen now. So what are the main obstacles in developing sustainable advanced materials? So is it renewable materials that can reach the same performances, or is it that there are not enough renewable raw materials on the market, Or is it the low level of collaboration along the value chains, the low traceability and trust of the resources and their impact, or the regulation complicating the
So thanks. While you answer the poll,
implementation of new materials options? So don't hesitate, and we will close the poll.
So while you answer,
Can you hear me, Julien?
Yes, I do. You hear me? I think there's some kind of delay.
Yeah.
So no problem. Technicalities, it's live. It always happens. So for the past 50 years and more, innovation has led to more and more performing and complex materials. And this for a wide range of industrial fields, and sometimes despite the environmental impact. What I'd suggest now is that we see, Alice, please, the results of the poll, and we collect the vision of Henning regarding the main obstacles. So Henning, according to you, what are the main challenges?
Well, I think this is most of these are pretty valid. I think the low level of collaboration is the one that I would say is the least valid that I'm seeing, because I see, particularly in our value chains, actually a huge increase in the level of collaboration. That's upstream collaboration, meaning we and our suppliers. Our suppliers are very focused, at least most of them are very focused on improving the environmental impacts of their materials, improving processes, working closely with us to bring better and optimized product into the marketplace. And when we look at the upstream, the downstream part of our customers, same kind of things. We're collaborating on waste take back programs, circular economy, overall improvement. I mean, generally, when we look at kind of advanced materials, the reason why just as a material, I think they already have environmental sustainable benefits, is that they usually improve a process or and make the process or the application less impactful or less burdensome from an environmental perspective. So they either require either they last longer, or they have a lower weight, use less energy, or they require less maintenance, or they require less additives or other materials, maybe lubricants and so forth, depending on where they're used. So all of those are benefits just by the material itself. The real challenge now is to look at the already kind of pretty advanced materials that we're using and reducing the footprint even further, looking at our carbon footprints, looking at the carbon footprint environmental impacts along that value chain, and reducing that. So that is one of the challenges. So we have, the first one there where it says renewable materials can't reach the same performances. In some areas, that is absolutely the case. So there's some, advanced engineering plastics that have such high melting points and have such great performance benefits that currently there are none or very few renewable materials that can reach that. However, not every application needs those. So there's a lot of applications that may in their specifications have the highest performance material spec, but it may make a lot of sense to go to a more sustainable option and do different material. And the same goes for like circular materials, right? So recycling recycled content doesn't necessarily mean less performance. In some cases, it may work, in others it may not. And that's one of the challenges we try to overcome. So I think they were all pretty valid. The one that I probably resonated least with me is the lack of collaboration, because I'm seeing a lot of that right now, I must say.
Yeah, but what is interesting is that it comes with 33% of answers. So people still maybe think that there's a need of higher level of collaboration. So that's also interesting, because it will make people engage into the collaborations. Regarding the applications, also we will go deeper into it later in the webinar. So I think we have a very interesting feedback here. And as you were saying, there are different ways of being sustainable. You can work on raw material, you can implement circular value chain, you can work at the design level also you can change the sourcing to source locally. You can ensure durability, so it also limit the impact on the environment throughout the whole life of the project, and also track emissions like Scope 3 emissions along the value chains. So briefly, could you explain a bit the approach of the Advanced Materials business unit regarding all these obstacles?
That's a great question, because you're absolutely right. So we have a huge toolbox that we can work with, and we try to use as many tools as possible, of course, wherever applicable, to improve our processes and improve the materials and improve the application. Usually it's driven by the customer. So depending on the customer needs and depending on what the customer is focused on, what the customer needs to do, we deploy different tools in the toolbox. We have, of course, our own sustainability goals and our own targets. So there's a lot of parts that we can already use internally, but then it depends on where the customer is coming from. So that goes a little bit back to that value chain collaboration. So in some industries, there's a lot of focus right now on sustainable materials, sustainable applications, either through customer pressure or regulatory pressure and so forth. And customers in those industries, of course, they are willing to collaborate more, they want to collaborate more, and we can bring more value to the table and then sit down with them and really work through the process and the application. See, so what is it that you need, right? Is it circular materials? Is waste an issue? Do we want to use recycled content in the product? Is it overall reducing the carbon footprint of the product at potentially maybe a different type of performance? Is it in the application? Can we do something to our products to actually make your application better? Maybe self-lubricating polymers and so forth, so you don't need to, so they last longer, there's less wear and tear, and you don't need to use oils and other lubricants in the process. For example, there's a lot of different kind of tools we can use, and we employ all of them. And we have a number of projects going, with customers to just work with them and increase the sustainability performance of our products in their applications. So we use them all. That's the beauty of it, and we can. The big focus, though, if you want to go back, just looking at MChem, kind of do a little navel gazing. We have very aggressive climate targets for MChem. So we absolutely look at our processes, of course, and the energy used in our own manufacturing and our own productions. The goal is to be climate neutral by the end of 2023. That is a very aggressive goal, and we're on the way to do that. That's through process improvements, of course, through transferring, moving from natural gas and other energy forms to electricity, and then to renewable energy sources, but also reducing the overall impact. We have waste goals, so we definitely want to reduce our waste as much as possible, and the waste that we want to recycle. So we have recycling operations, and we want to recycle as much material, our own waste as well as our customers' waste where possible, and then introduce that material back into our products and sell it to our customers, and which gives them the benefit. So there's a lot of tools internally we're already using, and then based on the customer's application, we can implement even more. I know there was a long answer, but there's a lot of stuff.
That's very interesting. What I can take from this is really about tackling a lot of challenges at the same time. So I think it's really, really challenging and interesting also, because where there are challenges, there are opportunities and business opportunities. So I think people are very happy to hear about that. You talked about recyclability, and I wanted to bring one topic here on the table when it comes to recyclability and advanced materials, is the topic of composite materials. So can we manufacture sustainable or recyclable composite materials?
As a general question, I would say depends. You're absolutely right. So we, of course, have a composites business, and then we also have a large business that is basically pure, or more or less pure polymers. So the moment you go look at the plastics and the polymers, they're very easy to recycle. So they're all very readily recyclable, mechanically recyclable too. So you basically don't need to put them through a chemical process or a pyrolysis process. You can just clean them and mechanically recycle them back into basically the same products. That's very easy, and that's already, they're readily recyclable. The moment you talk about composites, a lot of it depends on what the different parts basically of the composites are, and it depends on what in the end you want to recycle. It's extremely hard, or in most cases probably currently almost impossible if you have composites that are basically compression molded or in any other form really fused together to get them apart. So you will. So one of the innovations that I'm looking for, and I'm hoping that there's happening when we actually in our recycling centers look at that as well, is what can we do to get these different materials separated again and then recycle them and get the materials out of them. Currently, for example, when you look at carbon composites, I think on mainland Europe we may have the only industrial scale recycling facility for carbon composite materials in north of Hamburg in Wischhafen. There we can recycle carbon composite materials like wind turbine blades or bicycle frames and those kind of parts, but we recycle the carbon fiber. So that's the more impactful material, that's the more valuable material, so we can get that back out and use it back in other products. The matrix polymer or the epoxy or thermoplastic that's around that goes away in the process, so that disappears in the process. It's not completely lost because it turns into energy, but still it's not recycling. So that still is one of the big challenges, I think, for composite materials, and that's something I think that we have an internal innovation and startup, if you will, incubator called Growth Garage. They're very actively working with the startups and other innovative companies to figure out solutions and find solutions to such problems and challenges. I shouldn't say problems. I'm German, almost problem focused. Challenges.
Yeah, so if there are startups in the audience, and sure there are, I think you can shoot all your questions to Henning regarding collaborations. That's really interesting. So recycling is being developed. There are more and more effort to also scale recycling infrastructures. But in the end, and I think the example of composites is really interesting. Can we balance the environmental benefit with the environmental impact? For example, in the case of composites, we can access to lightweight structures and diminish the fuel consumption in planes, etc. So, how to balance performance and sustainability, which is the very own question of the Catch and Do today.
Which is I think that is the key question. And so in some applications it's pretty straightforward and kind of intuitive. For example, in the automotive industry, or you mentioned the aerospace, the airplanes. If the lighter the materials, the less weight, the less fuel is being used. So right there is an impact. In the end, calculating how high that impact is, that is that's where you need kind of in-application life cycle assessments. And we are very actively working on life cycle assessments for all our materials. And we are starting to work, at least with our customers, in these on in-use and application type life cycle assessments too, because then you have a good database and a data foundation that you can actually communicate from. There's a lot of applications where we know there's a benefit. Usually when there's an advanced material being used, it is to eliminate a certain issue or problem. Like I mentioned, the lubrication, for example. If you take if you take like wind turbines or anything else or bearings or anything else that moves a lot, if you have metal on metal, you need a lot of lubrication and you ultimately have a lot of friction. So if you use advanced materials like self-lubricating type polymers that can take a lot of heat and that can basically last forever, you don't have to lubricate, you don't have to replace the parts that often and so forth. So there are a lot of benefits to that right there, just looking at it. The key now is, and that's part of my job, and I've only been in that job for 4 months, so bear with me on this one, is to get the data and actually have a real database and foundation to say exactly, hey, if you use this material here, this is the material impact and this is the environmental benefit you get out of it. In a lot of cases we have it, but there's a lot of others where we don't yet, and we have to work on that. But ultimately, that is the goal. So not just to say, hey, the material is this, and we think, but to make sure that we actually have an environmental benefit in the long run.
So yeah, so you have to determine the environmental benefit and also be able to track and trace it, right?
Absolutely. Absolutely. And that's from a circularity perspective right there. That's one of the, so there's the data piece, and the other one is the beauty, as I mentioned, for a lot of these components, particularly with their polymer base, they're easy to recycle. We can get them back and we can recycle them. However, we need to get them back. So far, we're working closely with our customer, which are usually also manufacturers, to get their offcuts, waste, B products, whatever, back and recycle it. However, the end use, when the part is then in the wind turbine or is in the airplane or is in the car, a lot of materials get recycled in cars, the polymers usually don't. So there's a lot of these kind of pieces that just end up, we'd love to be able to figure out how to get this back. So this is another challenge from an infrastructure perspective. How do you actually get these materials back? We're ready, we have the recycling infrastructure, we have the recycling facilities, we just don't know yet how to get them back. So that's a challenge, for example, to figure out also. If there's somebody here listening and knows and has an answer, that'd be awesome. But currently they just end up in the mixed plastic waste and probably get incinerated, I guess.
Yeah, so I think people hear that, and if someone has a solution, they won't hesitate to contact you, I guess.
To so completely close this, we want to completely close that loop. Exactly.
Yeah, and the question of plastic recycling is the key question, if I understood correctly. We started to talk about the markets and the applications. So you talked about automotive, we talked about planes, we talked about also energy. In the end, can we address all markets with renewable materials, or is it specific to some markets like electric cars because they can handle high value materials, aerospace, medical? So well, which market can we address?
First, to kind of to be precise, the renewable materials, of course, that's the that's based on bio-based kind of feedstocks. When you look at more sustainable materials or circular materials, you can probably address a lot of markets, but not all of them. So there's still some limitations, usually regulatory limitations that make sense in some cases, and some of them may not. One, for example, is food. Anything with food where you need food grade materials. You can use recycled content, for example, in food, and of course you can use bio-based content if it's basically a virgin bio-based content in food contact materials. However, it has to be a very closely tracked recycling and waste loop, and with most materials the loops aren't quite as closely tracked, so that makes it very difficult, for example, to use recycled and circular materials in food grade applications. So that's one industry where I say there's a challenge and still something to work on the traceability basically and tracking the materials. And the other one is medical applications. So we have we also sell into medical applications. So we make, for example, kind of your artificial hips and shoulder sockets and those kind of things out of advanced materials. And of course, you don't want to have a recycled material there, and you usually don't get those materials back either. So so there are certain applications that will remain probably for quite a while, just virgin, singular, and that's okay.
That's really interesting that you mentioned these two applications of food and medical, because they are submitted to a lot of regulation when it comes to using new materials, food additives and so on. Here, finally, what about regulation? Does it speed up the transition by pushing the use of sustainable, renewable materials, or can it also slow down the transition due to other issues such as safety and so on?
So let's use food as one example, and the food grade and food contact regulation. They probably slow it down a little bit because they're very rigid. And when it comes to that, there's a good reason for that. I'm not saying that there's no good reason behind that, but that's probably kind of more hindrance. Usually, regulation, particularly when you look at the EU with regulations on chemical substances of very high concern and so forth, I think they actually push and drive improvements when it comes to that. So I know the EU, they did a pilot study on the product environmental footprint, basically disclosing the environmental footprint of a product, like an environmental product declaration, just the EU version of that. So that is something that may become a regulation that will really drive it forward. That means in the end, it'll help the consumer and anybody who decides on products to kind of know what is actually the impact of the product, and at the same time, it helps the manufacturers. It drives them to look actually at their products, do the life cycle assessments, and understand where are the hotspots and where can I improve. So in a lot of cases, it drives the development of more sustainable technologies. Same goes for any kind of circular economy and recycled content type mandates. When France, for example, or the UK started mandating minimum recycled content in packaging material and packaging plastics, that really pushed the industry forward. So if you're in that, a lot of folks in the industries may not like that, but ultimately the question was, does it drive development? It absolutely does. And so I tend to view it favorably and think it's going in the right direction. From an MChem perspective, we actually like to be ahead of that. So we like to be ahead of the regulation, and we always like to be a little, do a little more actually than they require, and that makes it exciting.
Yeah, so if you're a driver, so you want to drive the sustainability, so that's very, very honorable, of course. You talked about technologies and technologies to be implemented. We talked a bit about tracking and tracing, but you talked about technologies in general. Mm-hmm. We have a new poll for the audience. So Alice, could you please send this new poll about technologies or solutions to be developed?
Of course. Can you hear me, or do you want to read it?
We hear you live, I think.
Okay, good. Okay, good. So the question now is, what should be developed in priority to achieve sustainability according to you? So again, you can tick multiple options here. So the first choice is recycled and bio-based materials, better recycling infrastructures, digital technologies, more collaboration along the value chain, and sustainability by design. So I'll give you a few seconds, and in the meantime, Julien, I give you back the floor.
Yeah, thank you, Alice. So while people are finishing to answer the poll, I will ask you actually the same question, Henning, to you. So what are, according to you, the innovation gaps to better achieve sustainability?
Well, on the poll, I would say all of the above. I think they're all important. There's a number of challenges, of course, right now that that I personally are trying to tackle in the industry, and recycling infrastructures is a big one, and tracking and tracing of materials is the other one. I think these are both challenges that can be solved, particularly through technology, which is, I think there's a lot of really cool developments happening right now. But that's something I think that's not just me, but a lot of other professionals in my position are struggling with it as well. It's easy if you are a manufacturer and you have a few customers, or the customers are all part of one group and it's one application to develop recycling infrastructure. It gets very complex if you're basically in the middle of the value chain where we are, and the use of your products goes into thousands of applications in hundreds of different industries, and that makes the infrastructure and the take-back systems very challenging. It's easier on the post-industrial side with our direct customers, of course, because we have good relationships there. But the moment it goes further in the value chain, it's a problem. So that's the infrastructure part. The other part then is when we get something back and we collect it, is to track that material. Where is it from? Who made it? What's in it? Where has it been? All this is very important, because when you recycle material, you want to make sure that you don't have, substances of very high concern and so forth in there. So all this kind of compliance testing and risk assessment takes time and adds cost to the process and to the material. So the better your tracking and tracing system is, the better ultimately, the more streamlined your recycling and circular economy system. So I think those are the two, if I had to pick them, that I would pick right now.
Great, very interesting. So you mentioned track and tracing again. So you mentioned here for track and trace the goods along the whole supply chain before and post consumption or post use. You also talked about tracking and tracing the environmental benefit in use of the materials earlier in the discussions. So in the end, what are the solutions to ensure the trust and traceability of the environmental impact of these materials?
So from an environmental impact, there are already standards and technologies available. This is basically, the life cycle assessment and working together with your upstream customers and their customers on kind of value chain, cradle to a grave or loop, cradle to cradle type life cycle assessments. So those tools exist. The challenge there is really more getting everybody aligned and participating. So that's something that's already been done and that we can work on. When it comes to tracking and tracing materials, it gets a little harder because you want to have, and even if you just start at the waste standpoint, so you don't have the in use, but you have the waste. The moment the material becomes a waste, you need to basically be able to know, okay, so where was it collected? So what type of material was it? And then what were the different steps, like a chain of custody, basically going all the way through until it ends up back hopefully into your product as recycled material. And there are solutions, blockchain, there's a number of blockchain companies out there that provide these kind of solutions where you basically just pass it on. Everybody who owns it passes the data package on to the next one. And there also are, of course, basically old school solutions, which are more like audit based. In the end, it's probably like a combination of both. You want to make sure that you have ultimately verified claims. So if we sell a material that has whatever 30% recycled content, we want to make sure that it actually has 30% recycled content, and our customers usually want some kind of verification. In order to do that, you need to be able to trace it and track that. Not by direct insertion, but even on a mass balance basis, you need to be able what's coming in and what's coming out and understand the system. When it comes to infrastructure, it's a little harder because there's some systems in place for other industries. I'm thinking about the WE directive in Europe for electronics, where they basically work with local recycling centers and consultants, of course, and they basically also do like a mass balance calculation with the different manufacturers. So there are systems in place for plastics that doesn't exist yet. So that's something, for example, to think about. Is there a way that we can learn from other industries for kind of the advanced materials and plastics world as well?
Cross-fertilization, so between industries, very, very interesting. And we heard along the way that you have a lot of challenges that are also opportunities for collaboration that announced our next topic.
Awesome.
So you were saying that you were driving the sustainability along the value chain. So can you tell us a bit more about your role as an advanced material provider in driving sustainability across markets?
Well, basically, because as I mentioned before, we're kind of in the middle, right? Which is is a challenging position on the one hand, because you're kind of, you're not controlling any end point, but because you're in the middle, you can kind of influence up and downstream when it comes to the value chain. And that is a huge opportunity for collaboration as well. So there's a lot of collaboration, of course, from with our suppliers, and there's a lot of, I think, opportunity for innovation there as well. New materials, new feedstocks, use of closing loops. There's some materials that are not as readily recyclable as others. So is there a way to work with our suppliers to bring it back down to maybe a monomer level or a resin to feed it back into our production? And of course, a lot of opportunity upstream from a take back perspective, waste and circular economy, but also from an overall application and reducing, say, carbon footprints or any other environmental impact along the line. So I think the opportunities are vast, and we look in both directions because we are in the middle and work with both actively.
So how can people contact you to collaborate with you? Because you mentioned a lot of topics: recycling, the infrastructures, circularity, digital technology such as blockchain. So how can people collaborate with Mitsubishi Chemical Advanced Materials?
Well, one way is that if they're already working with MChem on any, whoever their contact is, they can just contact them because everybody's kind of involved in this. Then, I mentioned that incubator we have called Growth Garage. They can, of course, always contact them. And you have my information now, so you can always contact me. I'm on LinkedIn, and I mean, don't fill my inbox with stuff you want to sell me, but for collaborations, I'm always open. So please let me know, and I'll be more than happy to either work with you directly or pass it on to somebody who can. So that will be an opportunity. But it always helps if it's more than just a, hey, I want to sell you a blockchain tool.
Great. Thank you very much for all this information. So we have now about 20 minutes to start taking questions from the audience. So Alice, could you please start taking the questions? Thank you, Henning, for the information. That was awesome.
Yeah, thanks for the question. Thanks for the poll. That was kind of nice to guide through the conversation. I really enjoyed that, to kind of see where the audience, what the audience was doing, where they were ticking. That was nice. I think we didn't get the result from the last one, did we, or did I miss that? But that was.
Oh, we can see it. Sorry, my bad.
I talked through it, so that's maybe I missed it. But
yeah, you can see
awesome.
it here.
Cool. Yeah.
So
sustainability by design. I love that one too. That sustainability by design is key. Exactly. So that's because that's the paradigm shift, right? That's awesome. That changes the way you look at doing things and making things, and that's a huge challenge for most companies, including MChem, because you basically have to step back from what you used to do and figure out how can we actually do things not incrementally better, but really switch it out and create a how would I design this product today, knowing what I know rather than just improving what I have. So that's a big one. I agree with that one too. It's awesome.
Great. Thank you.
Thank you.
Good afternoon. I'm Regis, CTO of BLUMORPHO, and I have listened to the whole webinar, and my role is here to challenge you even more with a few more questions. They are not so tough, not so hard, but let me shoot. So you mentioned that there are currently some recycling efforts with carbon fibers, and as examples you mentioned bicycles, and you mentioned also wind turbines. It could be blades from wind turbine. And in fact, there's one product which is consumer, the other which is B2B, and you also mentioned the difficulty to collect the material. So from your experience, is it easier to collect from consumers, or is it easier to collect in the B2B environment where the people, there's on one way there's the motivation from the consumer, on the other way there's the obligation and the regulation. So which one works best?
Well, in general, I mean, we have basically two separate recycling operations. One is for the polymer and engineering plastics. The other one is for the composite material, which is the carbon one that you were talking about. I think in both cases, it's usually easier on a B2B environment. So even when I mentioned bicycle frames, it still is a B2B collection. So it's the bicycle manufacturer that has warranty claim because a frame broke or cracked or something. They collect them, and then we recycle the carbon fiber. The reason why it's easier to work with B2B, work with in the business on industrial environment is you get much larger volumes. It's the collection that makes it hard. But ultimately, even there, it's possible to do collaborations, right?
Densification in consumer is a challenge, and that's the responsibility of the one which is really close to the consumer to collect those data to make the densification. That's very, very interesting. Okay, you also mentioned that's a very interesting concept where an additive, a material can have some properties that could be considered as with a benefit for the environment. And if we consider this concept of sustainability by design, we could have at the end, even if the product, the material itself is not really sustainable, at the end we have a sustainability advantage. How advanced is this approach? Because for me, this is really a completely different way to design and to invent products. So is it something which is just at the beginning, or is it something which has been integrated into the future regulation? How mature is this idea?
I think the idea of using advanced materials to replace other materials to make certain processes more efficient, more environmentally sustainable and so forth has been around for a long time. So I think the real paradigm shift is now actually also looking at the advanced materials and looking at the process again and see where are further improvements possible. Because, you know, when we say, hey, this may be the material may not be sustainable, but it helps and makes the process more sustainable, yeah, that's a benefit. But it would be an even bigger benefit if you say the material is sustainable, it makes the process more sustainable, and we can actually maybe recycle it in the end. So I think that's where the thinking needs to happen and where it already happens. And that's, I think, fairly new thinking. I mean, design for environment and design for sustainability has been around for quite a while. In some industries more than others, but I think that's something that's really starting to catch on. I see that more and more, and I see that particularly with our customers, that they are very eager to work with their suppliers, which is us, and our suppliers then to develop kind of more holistic solutions. So it's not just here's a material that replaces something that's awesome, but really let's look at the whole picture and everything, and everybody at a table is trying to figure out how can we make this a better process, better product, better solution.
Okay, Alice, I think we have questions popping.
Yes, there is actually a question about styles. So we wanted to know here if Mitsubishi Chemical was also interested in textiles.
We're currently not. We're currently really not working with textiles. It's where it's interesting. A colleague of mine actually just posted that not too long ago or sent it to my inbox on some polymers that are used in textiles and recycling operations in the US. I think recycling. I think it was in this case it was more PET, but also like polyester fabrics, but also some nylons. How they get recycled. We're currently not in the textile business. I think there are other Mitsubishi Chemical companies that may be. But ultimately, I know for the textile industry, because I worked in that industry for quite a while, that is a big challenge, because there you talk about composites. Their composites are a little different, but it's also you know, multi-polymers or multi-material mix in one piece of fabric or one garment, and that makes the recycling more difficult. So that's not something that we're really working on. However, you know, if there's an interesting application solution, I'd be more than happy to talk about it. Where we have overlap with the textile industry is probably on the machines. So our products go into the machines, you know, that into the milling and tufting or whatever they do, machines of the textile industry. So there you'll probably find our parts.
Okay, thank you very much, Henning. A very detailed answer.
Thank you. I have more questions. Yes, you mentioned blockchain, and that's a topic that we like very much at BLUMORPHO. Do you already have some pilots in blockchain?
I think our Growth Garage incubator is working with some companies that actually offer blockchain solution for material tracking. I'm personally currently not working with any. So I know that MCE, which is the Mitsubishi Chemical Europe, they're already also working with a partner and doing some pilots. And I know that Growth Garage is doing it. But my team currently, my work currently, I'm not using it, let's put it that way. Yeah. But I'm hoping that they'll find a solution that they all like, and then we can implement something.
Yeah, because my big question behind is how do you make the link between the blockchain, which is purely data, and material, where it's really difficult to tag anything. So do you have solutions for that? Is it?
Not really. I mean, ultimately, you're right. Blockchain is just a tool, right? So blockchain is just, you know, while in the past you had like, you know, paper and files that you passed along, blockchain is just a tool to keep this, keep it secure, keep it confidential, and kind of make it trackable and traceable along the line. And so you ultimately still need the data entry, and you ultimately still need the audit process in certain spots in order to verify the data from a material perspective. But I mean, there are some solutions already that they're using, for example, for some conflict minerals and some of those, you know, metals that are to make sure that they're not from, you know, places where, you know, where there's child labor or civil war and slavery and so forth, where they use kind of either a tracer chemical in it, or use isotope analysis and then combine that with blockchain and trace it. So there's ways to do that. I've seen it with geos, with satellites as well, satellite imagery, and then just use the blockchain to basically transfer the data from one link to the next. But in our case, I don't have the solution yet. But ultimately, I know there still needs to be some auditing and some verification, I think, on the ground.
Yeah, and as you mentioned, it's so important to keep track. You mentioned this idea of building the data value chain. If I can talk this way, but it means that everyone must contribute to the blockchain and use the same tools. And so maybe you can start with one or two players, but three must be already extremely difficult to have all the data aligned. So are you already facing these difficulties, or do you have solutions?
In that area, not quite, because most of it is still done the old file way. So they're still just, you're still using just databases and files. It's probably going to be similar, like the ERP systems. Some use SAP, some use Oracle, some use whatever other ERP provider, and ultimately it still works, and you can still somehow communicate. And I think ultimately it's probably going to develop in a similar form. But I agree with you. Ideally, you have one system, but this is not that's not how the free market works. So
must agree on some kind of standardization of the data.
But I think it'd be a standard, exactly. That would be a standard. I mean, blockchain already is a standard, but I think there'll be a standard probably in the and there are already a number of standards out there when it comes to particularly tracing recycled material through the value chain, basically from waste to the different recycling processes. So there's a number of standards out there that already work. So I'm thinking there may be a combination of the two that will probably work.
And I was also thinking about your collaboration with your customers. As a material provider, you provide a lot of support to your customers to help them to choose the right material, or maybe adapt the material so that you can. That has always been done. So you already have this experience in design, and you understand your customers' need. Do you see some kind of transfer of this knowledge at the end? Maybe you know the product of your customer even better than they do, right? Can you comment on that?
Well, in the end, they know the customer knows the application, but yeah, there is a collaboration, right? So we bring a very deep and I would say, non-surpassed knowledge about those materials to the table. We've been doing it for a long time, and I mean, I've only been with Amchem for 4 months, but I'm extremely impressed with the knowledge and the depth of knowledge too on the different materials. I mean, these guys can do whatever you throw at them, they find a solution for it. Where the customer comes in, in some cases they need the material knowledge as well, but usually they bring the application knowledge. So they know their application better than anybody else, better than we do too. And so you bring the two together. Like when you work with in the aerospace industry or with the automotive industry, we don't know how to, I mean, some of us may know how to build a car. I don't, and our folks don't know how to build a car, but and how the different applications are, but we know how the materials need to be in order to make this application maybe a little better and take the friction out or take certain other things out. So that right there, you have a perfect combination. And usually that's how these partnerships work, right? So we are a solution provider to our customers. And from a sustainability perspective, same kind of thing. So a customer will come to us and say, hey, our goal is we want to have more recycled content in our materials. So we want to use, biocircular or bio-based materials and so forth. But it needs to be the same application. It needs to work the same way as this material does, or as this material does. And that's when we can help. We can really do that.
Do you see this request growing, or people are still into an education mode? They need to understand how to do, or they really want to engage into this new approach, this new material?
Depends on the industry. So there's some industries where this is absolutely growing, and then there's others where where we bring it to the table and we make the suggestion and push it a little bit on the industry, but they're usually very receptive. So this is something too that we kind of very proactively do with our customers and go into the market and say, hey, we can help you with this, and we can actually help you with this, solving not just your mechanical engineering problems, but also your sustainability. Add the sustainability value, if you will, on top of that.
Okay, you have clearly taken this ahead of the competition, and this is now a real differentiation for you. That's really interesting.
It's nice. I see it less as competitive. I mean, sustainability, we're kind of all at the same table. So we also are we're working very actively, of course, with our competitors on you know, on a association level and so forth. I mean, ultimately, you know, sustainability, if one just does it, that doesn't help anybody. So we need to raise it for everyone. So this is absolutely more collaborative, I think, than it is competitive.
And that's a marvelous conclusion. Thank you very much, Henning. And I leave the floor now to Julia for the conclusion. Thank you very much again.
Thank you.
Sorry, I was muted. Thank you, Henning, for your answers. Thank you, Regis, for the very interesting questions. So now we are reaching the end of our catch and do session. Before closing, we have a last poll to launch about who would you like to have more information about. So please, Alice, if you want more information about Henning and Mitsubishi Chemical Advanced Materials, you can select the answer. If you want more information about BLUMORPHO and our activity, please select. And if you want more information about the OASIS project, so this ecosystem of 12 pilot lines in advanced manufacturing, please also select. So while you're answering, I wanted to thank everybody who have joined the catch and do and this session. I hope you enjoyed it as I did with Henning. Thank you, Henning, for your answer. Thank you, Regis, for your questions. Thank you, Alice, for your overall support along the session. And before we say each other goodbye, I think Alice, you had an announcement to make about BLUMORPHO upcoming actions.
If that's okay. Allow me to thank everybody. Thank you, Julia. Thank you, Alice. Thank you, Regis, too, and everybody who attended. That's awesome. I look forward to hearing from you. As I said, I'm on LinkedIn, and I don't know if my email is up here, but you can find me. I'm easy to find, and I look forward to future discussions and interaction with you. Thank you.
We will also contact you about the people who have selected the MCAM and Henning choice at the last poll, of course.
Of course.
And thank you again, Henning, for your participation. Before closing, just the big announcement of Alice. So please, Alice, the floor is yours.
Yes, thank you, Julia. I hope you can hear me good now. So I wanted to talk to you about the Info Venture Summit. So Info is a biennial venture summit that takes place every 2 years then in Bordeaux. So this year it will be 13th and 14th of October in 2022 in Bordeaux. And we are innovating a bit because you can see 4 of the members of the editorial committee who usually define behind closed doors the topics that they want to invest in the 2 coming years. This year they have decided to open this discussion to the public. So we are having a webinar similar to this one in February, so less than 2 weeks from now, on the 15th of February at 7 p.m. And the thing is, right now we are open to your questions. So if you ask pertinent questions during the registration, you will be asked to join the floor and discuss directly with the investors present. So we will have George Grass, who is the chairman, member, managing partner of the AV8 Ventures Fund, Eric Benamou from Benamou Global Ventures, Emric Renard from Hardware Club, and Dieter Kraft from Trumpf Venture Forum. So I put the link for this webinar in the chat. So please don't hesitate to register if you're interested in this Venture Summit. And don't forget to put your questions, because it will be very interesting to have your input on this. Thank you.
Thank you. Thank you, Alice. So you heard her. So register and let's meet again on the 15th of February. So last minute to thank you again, Henning, for this session. It was awesome. Thank you to the audience for joining us today for the discussion. I hope you learned a lot of things as we did here at BLUMORPHO. And I wish you the best for this year. It's still time to wish Happy New Year. And stay safe, of course, in this situation. Thank you very much to everybody.
Thanks, everybody.
Very much.
Thank
Bye-bye.
you.
Bye-bye.
Stay safe. Bye. Thank you.
Bye.